This question says that we have a signal traveling through a circuit board conductor. So the conductor on the circuit board would be one of these little wires that you can see kind of in the lighter green color here running across this circuit board. By the way, this circuit board is one that was designed by some second years in one of my classes. So we have a signal traveling through a conductor, and it so happens that for this type of circuit board material that the signal will travel at half the speed of light as a kind of a rough approximation. So the question asks us, well, part A, what is this propagation speed converted to centimeters per nanosecond? So this is a question of dimensional analysis, so we really need to be able to remember the SI prefixes that we just had a look at. So the way that we would approach this question, first of all, we need to calculate the velocity, which we are told is half the speed of light. So that's 0.5 c. Looking at these numbers, this will give us 1.5 by 10 to the 8 meters per second as the velocity of our signal. Now this is in meters per second, and of course we need to convert this to centimeters per nanosecond. So the way that we would do that is by using a series of ratios. So let me just write this out one more time. So there's 1.5 by 10 to the 8 meters per second. I'm going to write it as a fraction. And now what I would like to do is find some conversion factors that are going to change from meters to centimeters. So I'm going to multiply by the ratio, and the way around that I put it is that I want the fraction with the meters to cancel. So here I have meters on the top line. That means I'm going to want to have meters on the bottom line of my conversion ratio. So I know that there's 100 centimeters to 1 meter. So multiplying by this ratio doesn't change anything because top and bottom are equal. But what will happen is that the units of meters here are going to cancel. So now I've converted to centimeters per second, but I actually need centimeters per nanosecond. So I have that 1 second is 10 to the 9 nanoseconds, 10 to the 9 nanoseconds. And so now I can go through and just check that I have the fractions the right way around. Okay, so meters will cancel here, seconds will cancel here, and the units that remain will be centimeters and nanoseconds, which is what I was after. So now I can just go through and multiply out all of these numbers. So here I can see 10 to the 8 times 100, give me 10 to the 10 divided by 10 to the 9, so this will leave me with 1.5 by 10 to the 1, and the units will be centimeters per nanosecond, and we might as well write that as just 15 centimeters per nanosecond. So that's part A. Part B of our question then says, how long will it take for the signal to travel 45 centimeters? So part B, how long will it take for the signal to travel 45 centimeters? Let's write down the things that we know. So I have a distance, which is 45 centimeters, and I have a velocity, which is 15 centimeters per nanosecond. So I need to find a way to combine this bit of information such that the answer will have units of time. The answer will have units of nanoseconds. And so the way that I can do that will be to take to get this nanoseconds to the top line of the fraction, I have to divide by it, right? So it's going to be 45 centimeters divide 15 centimeters per nanosecond. And so the division here of this fraction, we know that that's the same as multiplying by the reciprocal. So let me write that out as 45 centimeters multiplied by 1 nanosecond per 15 centimeters. And I see here, checking my units, centimeters are going to cancel. The units that will remain will be nanoseconds, which is what I was after. So now I can just go through and calculate based on these numbers. So that's 45 divided by 15, which is 3. So that is 3 nanoseconds.